Hey everyone, and welcome back to Knowledge on Ears. And in today's video, we're going to be looking at infrared flame sensors and how they really work. And so right now we're going to start with a pretty cool experiment. We're going to set a flame with this lighter, and we're going to see if it can actually detect the flame. So right now it's not detecting anything, but let's take a closer look. So right here, our flame sensor is connected to our Arduino, which is connected to my computer. And we're using the digital output pin right now for today because we just want digital output. We just want to know if there's a flame or no flame. We're not trying to take the analog output. So now, let's start. And make sure that you have guidance or adult supervision or something before you do this experiment because it's very dangerous. We're handling flames, so please do this with caution and make sure you watch out. So let's start. I'm going to light the flame. And instantly it's saying that a flame is detected, as you can see in the serial monitor. If I bring it closer, it's still going to detect it. If I bring it around. Now if I bring it back, it's still detecting the flame. So it's detecting the infrared light all the way farther back. If I bring it even farther back, it's still detecting it until I bring it all the way over here. And that's very far out of the frame. But as you can see, it's still detecting it as I bring it closer. So that's how it works. I hope it made a lot of sense. Make sure you handle this with caution before you do the experiment. Now let's get into how infrared flame sensors work. So now let's dive straight into how IR flame sensors work, or infrared flame sensors. This specific one is called the KY026 flame sensor, but there's many other types out there. So what do these flame sensors do? Well, basically, they detect if there is a flame. But how do they do that? Well, we know that when you heat up any object, the object starts to emit heat. It starts to emit thermal radiation. And there's many different types of radiation out there. You might have learned in school, there is an electromagnetic spectrum. And in this spectrum, there's different types of light, different types of radiation. There's visible light in the middle, the light that we can see, the different colors of the rainbow. And then there's other types of light. There's infrared light, there's ultraviolet light, there's gamma rays, X-rays, radio waves, so many different types. And infrared light is one of them that we can't see. And so the cool thing about infrared light is often when something is heated, it emits infrared light. So stuff like stars, very hot stars, also emit infrared light. And so this specific sensor, to detect a flame, since flames are hot and they emit infrared radiation, this black part tries to see if there's any infrared light around it, and then if it detects it, it says there's a flame. But one of the problems that could occur with this is that stuff like ovens or lights and lamps also sometimes emit infrared light, so it might be a little bit off, and it might say that there's a flame when there isn't a flame. Now let's dive into how the actual technical parts work and what's inside this black part. So now let's get into the complicated part. So over here, in this black part, we know that it's able to detect the infrared light, and then it tells us if there's a flame or not. But how does it do that? It does that through the use of a photodiode. So previously we've looked at diodes. We know that they only allow current to travel in one direction. We've looked at LEDs, light emitting diodes, and they take current and convert it into light. Photodiodes are the opposite of LEDs, the exact opposite. They actually take light and convert it into current. You can see that even the symbols are the opposite. There's arrows coming off of an LED, and there's arrows going in for a photodiode. So let's look at how a photodiode works. So for all diodes, there is a PN junction. And the PN junction is basically where the positive region and negative region meet. So in a PN junction, in the P region, that's where there's a lot of holes and less electrons. So what are holes? Holes are basically they're not actually particles. They represent where there's an absence of electrons. And electrons are obviously just electrons. So in the P region, there's a lot of more positively charged carriers. In the N region, there's more negatively charged carriers. Now, what happens where these two regions meet is called the depletion region. And that's where electrons and holes diffuse, they recombine, and they leave behind these immobile ions. So they're tightly held together, they don't move. So there's negatively charged ones and there's positively charged immobile ions in this depletion region. So closer to the P region, there are negatively charged ones. Closer to the N region, there's positively charged ones. And what that does is it creates an electric field across this region between these different charges. So now, what happens in a photodiode is we apply something known as a reverse bias voltage. And what that does is typically we know that we apply a positive voltage to a positive side, we apply negative voltage to negative side. What happens in reverse bias is we flip it around. We apply a negative voltage to the positive side and a positive voltage to the negative side. So what happens when that happens is the depletion region actually widens and the electric field gets stronger because of different physics properties. And so when it gets stronger, that actually blocks normal current from passing because obviously we're flipping over the voltage applying method. So now, when we get to the light part, how does this even help us detect when there is like infrared light, when a flame is there? So when infrared light hits this depletion region, that actually allows us to create new electron-hole pairs. So the electrons and holes actually come together and create these pairs. And obviously, since there's an electric field between these like widening depletion region and there's an electric field between these ions, these immobile ions, that actually takes these electrons and splits them apart. So electrons on the N side, these holes on the right side, and on the P region, and that actually creates this photocurrent. So a photocurrent is basically the current created from light, photocurrent. And so how does that actually help? Well, when a current is created from this IR, from this infrared radiation, the more infrared radiation there is, the more electron hole pairs there will be, and the larger the current will be in the end. And that makes the amount of infrared light there is and the current created proportional. So the light and the current is proportional. And obviously, let's say there's a bigger flame, there's a huge flame that emits more infrared light. And in turn, that will create much, much larger current. And that will tell the Arduino or tell whatever microcontroller is doing the process, it will say, wow, there is a much bigger flame, much more current is being generated. So the output is current. So I hope that made a lot of sense. I hope the experiment at the start made sense too. It is quite a bit of a complicated concept, but it is also super interesting. So thank you so much for listening. Bye.